Okay, hello everyone. Welcome to this wonderful talk. We have a great audience this evening, and I know a lot of you are also watching on YouTube, so welcome. Today I'm going to talk about analyzing live smart contract systems and how we do it at L2Beat. And my name is Piotr Szlachciak. I'm the CEO and co-founder of L2Beat. And if you don't know L2Beat, well, we are doing research and analytics about Ethereum L2s. And if you would like to have some context to what I'm talking about, open up our webpage, do some browsing, and you'll see what the talk is about. And now I'm going to state the problem that we face. We are listing more than 100 projects right now, and this is across L2s, L3s, bridges. We're analyzing all of them, and by analyzing, I mean not only displaying TVL, but we actually do in-depth research about those projects. We look at the smart contracts, we look at the upgradability, the security guarantees, and we would like our information on the website to be up to date. Now, this is a challenge because if we make some simple assumptions, so we have 100 projects, let's assume every project does an upgrade every 6 months, right? So like a usual cycle, they do the marketing, they do the preparation, audits, and so on. Every 6 months, they release a new version. So what this gives us, 100 projects, 2 updates per year, 200 updates per year. So we have 4 updates per week. And in reality, right, we actually see changes happen every single day. So obviously, this is unsustainable if we wanted to do this manually. We tried this at the start. We had very little projects. And it was possible to sit down, do the research, very manual work, look at the smart contracts, try to get the sense of how it all works, and then do a write-up, and it would essentially come down to presenting our findings on the website. Now, if we would continue this process, it would actually be completely unsustainable because of all of those upgrades. The moment we publish the information, it instantly becomes stale because one of the projects upgrades, and so we had to come up with a solution. And the solution is, of course, automation. So, but the key insight into all of this is how can you do this, right? Because it's not just downloading values from an RPC. You can use an RPC for things like TVL because you just select the tokens that you want to know about and you query the balance of function. You cannot do this for research. And so we had to be clever. Now, we designed a system that we call Discovery. And this is a system that does recursive scanning and analysis of smart contract systems. And I think the best way is to show you an example. So an example that I picked is actually signups. And the reason I picked signups, it's a bridge, is because the smart contract architecture is actually really simple compared to some other projects. And the way you can start to think about what we do is starting on the left. We have the signups bridge smart contract. And in this smart contract, we can see that it has some fields, right? It has an admin field, it has an address of the wrapped Ether smart contract, it has some access control pattern. And so you can see that then the admin is read by our system, and we see that it points to the proxy admin smart contract. Then the proxy admin has an owner, which is the time lock controller, and the time lock controller has an admin, which is the bridge multisig, and this is actually the controller of the entire system. And we were able to draw this diagram through using our discovery tooling that recursively, as I said, goes through the smart contracts, calls the methods, gets the values, and maps the entire system. And I think it's also time for a demo of how it works. So what I have prepared here is a very minimal setup that will try to do the work that our researchers are doing normally. So what we have here is a minimal config file for using Discovery, our tool, to do this mapping of the synapse system. The initial address, this OX2796, right, is the address of the synapse bridge. And so what we're going to do is just say we want to discover on the chain Ethereum the bridge synapse. And we're going to run this script. And I'm just going to show you the output because it's very fast. But we're analyzing this smart contract. And what we see is we have detected it's actually a proxy, right? So now we actually read the implementation. And the implementation has some methods. We call those methods. And we have this new relatives found, right? I know that one of this is the address of the wrapped ether smart contract. And the other is the proxy admin. So you can see then we're analyzing the wrapped ether and then the proxy admin. And we have this recursive thing where we just query the values for all the smart contracts. Now, then the researcher would go into this other file. This is the discovered JSON file. So the config produces the discovered file. And here you can see the exact stuff that I was talking about, the values that were discovered, the recursive method. And we can see some values like default admin role, governance role, node group role. The researcher and I will know that this is actually reminiscent of a pattern that you can find in Open Zeppelin smart contracts called access control. And the cool thing about the discovery tool is that it actually allows you to incorporate some of the knowledge that you have about the smart contracts and automate getting those values. So what we're going to do is do some overrides. And we're going to say that for this smart contract, we want to override some fields. We're going to add a field called access control. And this field is going to have a handler. So we're specifying now what are we going to do, how are we going to get the value of this field. And similarly, we can see that the time lock controller also has those roles. So we're going to use the address of the time lock controller, and we're going to add the exact same overrides for the time lock controller. So now that we've done that, if we run our discovery again, it is going to discover some more stuff. So now you can see that the synapse bridge has this access control field, and it has those roles fetched from the blockchain. So this is kind of how our researchers would use the discovery tool. And the cool thing about it is now we can also get the source code of those smart contracts. So in the .code folder are the source codes for all of the smart contracts that we have downloaded from Etherscan. So you can see the Synapse bridge, and because it's a proxy, we have the source code of the proxy, and we have the source code of the implementation. Now, looking at this, you can see that it's so like a lot of folders, a lot of files, a lot of comments. It's like very overwhelming. How are we going to read all of this? And this is where the next part comes in, which is we're not. The best part is it's all automatically flattened into a single file. We remove the unused stuff so that it's very easy for a researcher to actually read the source code. So now, instead of having those two folders, the implementation and proxy and all of those have nested folders, and you're going to try to figure out what's what. If I open the Synapse bridge folder in the flattened file, I have the source code for the Synapse bridge, and it's only the stuff that is actually used. And I have the source code for the proxy, again, only the stuff that is actually used. So as a researcher, I would only look at those. So I don't have to do this thing where I go to Etherscan and browse through those 65 files and like in this very bad UI. So that's it for the demo. And if we go back to the presentation, what's the logical next thing? Now that we have the ability to do automated research and getting all those values and being able to configure how we get those values, well, the next logical thing is to run it in a loop. And so we run it in a loop, and every hour we go through all of the projects that we have configured, we get all of those values, and we compare it to what came an hour before. And so this is an example from today, early in the morning. A chain called Dairy had an upgrade, and they changed the required stake from 2 to 3, right? So this is the type of thing that we detect. And then the next logical thing is we can automatically update our website. So whenever things change, we can, so for example, you can see here, this is an excerpt from our webpage for Arbitrum. And you can see the Security Council participants, right? If someone were to add people there, remove people there, this probably doesn't affect the security of the system. This probably doesn't require a human to go in and like write something specific about how the system works now. It's a simple change. So those changes can be automatically reflected in the website. And for more complex changes, let's say that the implementation changes for some of the contracts, we just say, okay, this system is now under review, and one of our researchers sits down and actually runs the discovery locally, reads the source code, and figures out what has changed. And actually, the one other thing that I wanted to show you, so we'll go back to the code, right, is the ability to figure out what has actually changed. And I think it's best if I show you this on a different example. What I'm going to do is show you how we can compare projects to each other. So you might have heard about optimism and superchain and OP-stack chains, and you might think, okay, so those OP-stack chains are basically all the same, right? Well, no, and I'm going to show you one example. So what we're going to do is we're going to run a tool called PowerDiff. So discovery was one thing, PowerDiff is another thing, but basically it allows you to compare two projects together, right? And I'm going to pick base as one of the projects, and the other project is going to be mantle. And so I'm going to run the PowerDiff. It's going to process the files that I have, and it's going to open this like web page. And so now I can browse through the files. Some of them are added, some of them are deleted, some of them have actual differences. And so I can choose a file to like look into. And for example, the difference between base and mantle in one of the files, like the L2 output oracle, is that one of the system has those value and mint variables, and the other has like mint value and if value, right? So there are differences that we can pick up on using the research tools that we have built, and this is how we can actually know, what did they do when they deployed the projects. So coming back to the presentation, we have some advanced features built into this entire tooling. Like I showed you code flattening, I showed you handlers, I showed you project comparisons. I haven't showed you, but I'll talk about the heuristics and templates. So you might think, okay, that's all well and good, but I have to like create config files for all of the projects, and I kind of have to repeat the research. What if the projects are similar? And this is what we actually find, that a lot of projects are reusing the same patterns, the same things. So this is where heuristics and templates come in. For example, a lot of projects use the same proxy types, right? So as you've seen before, we can automatically detect that a smart contract is a proxy. This is what we're using heuristics for. One example would be, how do we know a smart contract is a Gnosis safe? Well, the way we do it is we actually check if the value at storage slot 0 is equal to the same value that is returned from the call to the master copy function. It's an example of a heuristic, and this is how we detect Gnosis safe smart contracts. If we have a huge list of those heuristics, and this is how we can detect different types of contracts. And for the templates, basically, these configuration files that you saw before, you can reuse them for different projects, and this reusing is templates. But also, when we define projects on our website, we can reuse the definition. So all OP-stack chains are kind of reusing the same template, so that the researchers don't have to do as much work when they describe it. And this kind of solves the problem that I stated at the beginning, which is we have all those projects. How can we manage the constant updates, the flow of everything? And now let me talk about something that is like coming up, that's not yet really built, but that's being built right now, is automatic detection of project permissions. So this is again an excerpt from L2Beat's website. These are the permissions in the optimism blockchain. And what you can see is that it's kind of hard to see what's going on. We have the proxy admin, we have the proxy admin owner, the proxy admin owner multisig, and this multisig is actually two multisigs, the foundation and the security council. And I know this, but it's not easily readable from here. And I was thinking maybe we can change the format to sort of say, these are the entities that have control of the system. And going through the entities, we show what they can do. And also, we are building this in an automated way. So again, not to overburden the researchers. Once the system detects that, oh, there is some owner of the smart contract, it gets automatically assigned as this entity that we want to list in this permissions. So this is what's coming in the future with this tooling, and it basically allows us to keep up, hopefully, with the constant flow of new projects that are coming. And so I guess it's time for me to say thank you, and if you have any questions, I'll be happy to answer them. Okay, we have one question.
Sorry, we missed the beginning. Maybe you mentioned it. This tooling, is it open source and available?
Yes, so this tooling is open source. It's part of the L2Beat repository. But open source doesn't exactly mean easy to use outside L2Beat. So you can read the source code, you can see how we're doing it. But I think you'll find it quite hard to run it for your own things. Oh. But I encourage you to do.
I'll try it.
Yeah.
A few targets we need to test. And I had a second question. How many researchers do you have at L2Beat?
Currently, we have 4 researchers. This is the size of our research team.
Okay, great. Thank you.
Thank you. Okay, do we have any more questions? Okay, then thank you very much. You have been a wonderful audience, and yeah, thank you.